Hello friends, in today's video we are going to discuss a question in which there is a cannon which is sliding through a wedge which is inclined at an angle alpha to the horizontal, and this question it is asked that find the difference between the capital T minus small t. That means what is capital T? Capital T is the time when the bullet will be fired. That means uh, let's suppose this is the cannon. Inside the cannon there will be many bullets. Let this is the bullet and this is the same bullet as that of. So it is clear that if it will move distance L, it will also move distance L. That means capital T will be the time when the bullet will reach there, and also included the time when it process inside the when the process is going on. That means we know that if a cannon is fired, there are many internal collisions inside the cannon. So this is the time we take time dt, and this we have to find. That means t minus dt, capital T minus small t is equals to dt. This we have to find. That means what will be the time taken by this cannon for the internal collision and when it will shoot. So we are going to find firstly capital T. So here we'll use first equation of motion, which says that capital V is equals to small u plus a into t. Since in the question it is given that the bullet is fired by momentum p, which is equals to mass time velocity, in the question it is given that the mass of the bullet is very negligible as compared to mass of the cannon. So we can neglect the mass of bullet, then p equals to v. Then we are going to write the equation of motion along the inclined plane. That means along the inclined plane. So we know that and along the inclined plane there will be acceleration jet g sin alpha, and there will be acceleration g cos alpha. So if it is alpha, then it will be also alpha, then it will be also alpha by corresponding angles, and by this will be p cos alpha, and we will write the equation of motion by final velocity will be p cos alpha equals to initial velocity of the bullet was 0, as it was also released from rest. Acceleration will be g sin alpha, this will be capital T, this will be capital T, and we get the value of capital T as p cos alpha upon g sin alpha. Now we are going to find small t. Small t is the time when the cannon will reach there. So we are talking about the cannon. So here also we will use equation of motion, that is let when the cannon will reach there, its velocity along the inclined plane will be v dash. So we will writing the equation v dash equals to its initial velocity was 0, then there will be 0 into this acceleration will also be g sin alpha along the inclined plane, then it will be, and there will be t. So you will think that how we will find v dash. Now we know that this is alpha, so this will also be alpha, and if this is alpha and this is L, then this will be L sin alpha, this will be L sin alpha. So we will use work energy theorem for finding its velocity. Now using WET, that says work done by all the forces is equals to change in kinetic energy. Since only the gravity who is responsible for the movement of this cannon, so we'll write here mgh. Since mg is doing positive work done, then we will write here plus, so no meaning of writing here plus, so we will, and its final velocity will be half m v dash square minus 0. That means v is equals to m will be m cancel out under root 2gh, and at the place of h we can replace here L sin alpha, as we have find here L sin alpha. We will put here the value of L sin alpha, then there will be under root this v dash will put, then there will be under root 2 GL sine alpha upon G sine alpha is equals to T. Now subtracting equation 1, now 1 minus 2, we get, we'll let the time there, T dt is equals to P cos alpha minus under root 2 GL sine alpha upon G cos alpha. This was the answer. Thank you.